Okay, so today we're diving into something truly wild. We're talking about neutron stars. And let me tell you, these are, without a doubt, some of the most extreme, most violent objects in the entire universe. They are absolute cosmic monsters, born from the explosive death of giant stars.
And right here, this is the core paradox that makes them so mind-bending. You can think of them as giant atomic nuclei. I mean, they're tiny, maybe only a few kilometers across, but they pack the mass of an entire star into that little space. Just let that sink in for a second.
So that's really the big question we're tackling here. How is it even possible for something so small, cosmically speaking, to be so unbelievably massive? We're going to unravel this mystery together, and to do that, we have to start at the beginning. See, to understand a neutron star, you first have to understand how a regular, living star actually works. Its whole life, its entire existence, is built on this really delicate but incredibly powerful equilibrium.
A star's life is basically a constant tug of war. On one side, you've got this immense force of gravity, always trying to crush the star inward to make it collapse on itself. But fighting back, pushing outward, is the explosive energy from nuclear fusion happening in its core. As long as those two forces are perfectly balanced, the star is stable and everything's good.
But for the real heavyweights of the universe, stars that are many, many times more massive than our sun, that balance can't last forever. And when their fuel finally runs out, the end isn't quiet, it's catastrophic. The speed of this final collapse is just staggering. The star starts burning through its leftover fuel in this accelerating frenzy. I mean, what took centuries, fusing carbon into neon, suddenly takes just a year for neon to become oxygen, then months for oxygen to become silicon, and then, in just a single day, all that silicon burns into iron.
And then, that's it. Game over. Iron is basically nuclear ash. Fusing iron doesn't release energy, it actually consumes it. So with no more fuel to burn, the fusion engine at the heart of the star just shuts down, instantly. The outward push is gone and that fragile balance is shattered for good.
What happens next is both awesome and terrifying. With nothing holding it up, the star's core collapses under its own crushing weight. The pressure becomes so intense it literally smashes electrons and protons together to create neutrons. The rest of the star comes crashing down at a quarter of the speed of light, slams into this new, unbelievably hard neutron core, and bounces off in the most powerful explosion we know of, a supernova, an event so bright it can outshine entire galaxies. And after all of that unbelievable cosmic violence, when the dust finally settles, what's left behind is that crushed, dead core of the original star. And this is our newborn neutron star. So just how extreme are we talking? Well, try to picture this. You take the mass of about 1 million Earths, and you crush all of that stuff down into a sphere that's only about 25 kilometers across. We're talking the size of a city. When you put it next to our own sun, the numbers are just insane. Its diameter is a tiny, tiny fraction of the sun's. Its surface is over 150 times hotter. And its gravity? Well, its gravity is the second strongest force in the known universe, beaten only by a black hole. The density is almost impossible to wrap your head around. To put another way, a single teaspoon of material from a neutron star would have the same mass as Mount Everest. That's billions of tons of stuff packed into something the size of a sugar cube. Okay, so we know the outside is extreme, but what if we could actually take a journey inside one of these things? What would we even find? Well, as you go deeper and deeper, the pressure becomes so completely overwhelming that the atomic nuclei themselves get crushed together until they're touching and merging. They rearrange themselves into these bizarre shapes that physicists have, and I am not making this up, named nuclear pasta. And it's believed to be the strongest material in the entire universe. And yes, they really do call it that. Depending on how deep you go, the nuclei can form shapes that look like gnocchi, or spaghetti, or even lasagna. Now, these aren't just funny names. They're actually describing the real geometric structures of this ultra-dense, bizarre matter. But what about the very center, the core? The honest truth is, we don't really know. The physics at play here are so extreme that they go beyond anything we currently understand. Do the protons and neutrons just dissolve into a sea of their building blocks, called quarks? Does it form something even weirder, like strange matter? It is genuinely one of the biggest mysteries in all of astrophysics. Now, as incredible as a single neutron star is, you know what's even crazier?
What happens when two of them meet?
So if you have two neutron stars orbiting each other, they're constantly sending out energy in the form of gravitational waves, actual ripples in spacetime. This makes their orbit shrink, pulling them closer and closer in this cosmic death spiral, until they finally smash together in an explosion called a kilonova.
During this insane collision, a huge amount of raw neutron-rich gunk gets sprayed out into space. And in the extreme heat and pressure of that explosion, all that material gets rapidly reassembled into heavy elements. This, right here, is the universe's main factory for things like gold and platinum. And the collision is so massive that what's left over usually collapses and forms a brand new black hole.
So why does any of this matter to us, way over here on Earth? I mean, these are violent, super distant events. What's the connection?
Well, the connection is actually profound. It turns out that to create the elements that make up our world and our technology, stars have to die twice. First, a huge star has to die in a supernova just to create a neutron star. Then, two of those neutron stars have to collide and die in a kilonova to forge the heaviest elements in the universe.
Think about this for a second. The gold in your jewelry, the platinum in your smartphone, the uranium we use in power plants. Every single atom of those elements was forged in the collision of two neutron stars, probably billions of years ago. Those atoms then traveled across the galaxy for eons before they ended up in the cloud of dust that would one day form our solar system.
So our modern world, our technology, it's all literally built from the ashes of these ancient stellar ghosts. It's just an incredible reminder that we are deeply connected to the grand, violent, and beautiful life cycle of the cosmos. Which really leaves you with one last question to ponder. What other secrets of our past are written in the stars?